Show that the limit as x approaches 2 of the polynomial 3x plus 2 equals 8 using the formal definition of limit. You can see the outline of how we're going to do this proof. We're going to use this general outline for most of these problems. We seek delta such that for every positive epsilon, 0 less than x minus a absolute value is less than delta, produces the absolute value of f of x minus a less than epsilon. Okay, let's continue. Here, for this problem, we have a equals 3, f of x is 3x plus 2, and the limit L is equal to 8. So let's reword what we had in the cloud above. Thus, we seek delta such that for every positive epsilon, 0 less than the absolute value of x minus 2 less than delta produces the absolute value of 3x plus 2, that's our f of x, minus our limit 8, is less than epsilon. Okay, step 1. We're going to relate the absolute value of f of x minus L and the absolute value of x minus a. Okay, to do this, we're going to assume that 0 is less than the absolute value of x minus 2 is less than delta. And we're going to show that the absolute value of 3x plus 2 minus the limit a is less than epsilon. Okay, let's do it. We relate the absolute value of 3x plus 2 minus 8 and the absolute value of x minus 2 to decide what to use for delta. So we're going to start with the absolute value of f of x minus L. And that's the same, that's equal to the absolute value of 3x plus 2 minus 8, which is equal to the absolute value of 3x minus 6, which is equal to the absolute value of 3 times parenthesis x minus 2, which is the absolute value of 3 times the absolute value of x minus 2, but the absolute value of 3 is just 3. So that is 3 times the absolute value of x minus 2. And that will be less than 3 times delta because we made an assumption that the absolute value of 2 is less than delta. Think about it. Okay, so we want this to equal epsilon. Thus we choose the last portion, 3 times delta, to be equal to epsilon. Right, epsilon equals 3 times delta, and then solve that little equation for delta. You get delta equals epsilon over 3. There it is. That's the delta we're going to use in step 2. We're going to assume that the absolute value of x minus a is less than delta and choose, for this case, delta equals epsilon over 3. That will be good enough for us to show by substitution that the absolute value of f of x minus L is less than delta. Okay, so we are assuming absolute value of x minus 2 is less than delta. We're letting delta equal epsilon over 3. Now let's do our proof. Then the absolute value of f of x minus L is the absolute value of 3x plus 2 minus 8 is equal to the absolute value of 3 times the absolute value of x minus 2, which is 3 times the absolute value of x minus 2, which is less than 3 times delta, which we said earlier. Now replace delta, that's equal to 3 times epsilon over 3, and the 3's cancel, and we get epsilon. So here we've shown the absolute value is actually less than epsilon because there was an epsilon sign in that entire line. Conclusion, thus we've shown that the limit as x approaches 2 of 3x plus 2 is equal to 8.